Welcome back to question 3. We're now going to use an alternative method to answer this question. We're going to be going through method 2. So hopefully you watched the video on method 1, but in this video we're going to go through method 2, which is the minimum cut method. And there are some definite advantages to using the minimum cut method. And in some of these questions that we're about to go through, you might even say it's easier. So make sure you stick with me for that. All right, so question 3. It says the network diagram below shows the local road network of town M. The numbers on the edges indicate the maximum number of vehicles per hour that can travel along each road in this network. The arrows represent the permitted direction of travel. The vertices A, B, C, D, and F represent the intersections of the roads. Part A says determine the maximum number of vehicles that can travel from the entrance to the exit per hour. So this is a flow question, and it's asking us to find the maximum. It's asking us to find the maximum flow. We know that the maximum flow is equal to the minimum cut. So what we need to find is the minimum cut, and this is what this method is all about. Remember, with the minimum cut, there are different ways of going about it, but if you wanted to use trial and error, what you're trying to do is cut through this graph with the minimum amount of numbers possible. So you know that for this one, that cut would be 1500. And so too at the beginning, that cut there would be 1500. So the number to beat is 1500. So you're going to keep drawing cuts through it. I would definitely recommend doing this in pencil until you find that minimum cut. So for instance, for this one, I would go 620 plus 840. So I'd come here and I'd go 620 plus 840. Well, that's 1460, which is better than 1500. So 1460 is in the lead at the moment. And then you'd keep on going. So maybe I cut through here, here, and here. Now, remember, whenever there's backflow like this, you don't count that number. So this would be 740 plus 320 plus 620. So if I do this, I'm going to go 620 plus 320 plus 740. That's going to be 1680, which is bigger than 1460. So you just ignore it. That is no good. You wouldn't even write that one down because you've already got one smaller than it. Then the next one we might do is this one right here. Sorry, so I'll do this. Now this looks very promising, and the reason why this looks promising is because you've got two backflows. So you wouldn't count that one, nor would you count that one because they're backflows, meaning you just plus 650 and 680. So if we come here, we're going to get 650 plus 680, and that's going to be 1330. So that is very good. 1330 is smaller again. And if you were to keep on doing this, what you're going to realize is that 1330 is going to be the smallest cut you can make. And remember, your minimum cut is equal to your maximum flow. So your answer will be 1330. If we now look at our examiner's report, you can see that 24% of people got this correct. The answer was 1330. This question was not answered well. Many students did not demonstrate they had even tried to find the minimum cut, which leads me to believe that VCAR expected people to use method 2, the minimum cut, to do this. All right, so far, so good. Again, make sure you do this in pencil so we can now get rid of all the other cuts that we made and just clean up the graph a little bit. The next part says, the local council plans to increase the number of vehicles per hour that can travel from the entrance to the exit by increasing the capacity of one road. Complete the following sentence by filling in the boxes provided. The road that should have its capacity increase from vertex what to vertex what. So what we want to do here is we want to increase our maximum flow. So that's right there. We want to increase the maximum flow. If I want to increase the maximum flow, by necessity, that means I'm going to have to increase the minimum cut because my maximum flow is my minimum cut. Therefore, if I need to increase one road to increase the maximum flow, I'm going to have to either increase 680 or 650 because those are my minimum cuts. This is why this method is so powerful, because you now have a 50-50 chance of getting this correct. You're either going to increase 680 or 650 because you know if you want to increase your maximum flow, you need to increase something on your minimum cut. Now, once we're here, we need to figure out which of these we would increase in order to make this thing flow more. If we were to look here for a moment, we know that we have the full 650 cars coming through. Let me do this in another color. Let me do this in blue. We know that we have the full 650 cars going through this way. If we have 300 going up that way, how many do we have going through that way? Well, I have 650 minus 300. That means, 650 minus, Yes, so if I had 650 cars going through this way and I send through all of them there, So I've got 650 cars going through that way. And I'm saying if I send all of the 300 up that way, that means I'm left with 350. And this is actually where it's actually better to think it from the beginning. So scratch that. Let's think it from the beginning. And this is actually why I began with method 1, because at the end of the day, I feel you can't escape it. You have to think it through in this way. So you'd have to think it through like, all right, I've got 1,500 cars going through this way. I've got 700 coming up that way. I've got 680 going through this way, which means it's pointless for me to send 700 that way. I should only send 680 that way. Once I've got 680 coming through that way, then I've got 680 going through this way. Then I want to send, this 680 needs to split into 620 and 320. Well, I know that if I've got 620 and 320, that means I can send a maximum of 940 up that way. If I can send a maximum of 940 through that way, and we now go back to our other one, to our other pathway, I'm sending 1,500 through that way, 650 through that way. If I send 300 up this way, me sending 300 up that way, plus the 680 here, 300 plus 680 is 980. I know I can only fit 940, which means I should only send up 260 this way. And notice how this is exactly what we're doing in method 1. You can't really escape it, I feel. So now that I'm sending 260 up that way, I'm going to come back to this 650 and say, all right, 650 minus the 260 here, 650 minus the 260 means I'm going to be sending 390 through this way. And immediately what you can see is that this has the capacity for more. This has the capacity for 740, but I'm only sending 390 there, which means I should increase this one right here. I should increase 650 in order to increase the flow of this. Another way you could think it through is just like, what would happen if I added more here? No, I feel like you have to do it that way. Because if you just said, all right, what would happen if I added, I don't know, if this full thing was 940 here, 620 plus 320, and you send this full 300. No, scratch that. I feel, and correct me if I'm wrong, I feel like that's the best way to do it. To think it through from the beginning, work your way across and say, all right, I have more capacity going through here, which means I need to send more through that way. And now you can see why I showed you method 1 first. I feel like you cannot escape it. And that's going to become even more evident once we move on to the final part here. So that means we have to send it through from A to D. That road has to increase. From A to D, this has to be the road that gets bigger. If we look at our examiner's report, you can see that 38% of people got this correct. The answer was, the correct answer was A to D. That's a good amount of people. And I have to believe the reason for that is because if you use the minimum cut, you had 50-50 odds of getting this right. If you use the minimum cut. Also, if you just kind of thought it through logically, which is kind of method 1, isn't it? Method 1, do you know what we should call it? This just came to me. We should call it kind of like the logic way. I'm going to copyright that. No, tell me if you can think of a better name. But that's it. All right, let's now move on to the last one here. You're probably sick of this question. I know I am. It says, what should the minimum capacity of this road, referring to the road from A to D, so what should the minimum capacity of this road to maximize the flow of vehicles from the entrance to the exit? So in other words, what should I increase this by in order to get this to flow as much as possible? Well, if we look here for a moment, you can see that I have 650 cars going through this way, and then only 390 going through there. I know it has a capacity of 740. So you might say, well, what happens if I was to actually increase this so that after I've subtracted away my 260, I have 740 left? Well, that's obviously going to be 1,000, right? So if I had 1,000 minus 260, that's going to leave me with 740. So you might say, maybe this, and I'll do this in pink. Actually, let me do it in orange. Maybe this should actually be 740. Because if it's 740, that means I can now, this should be 1,000. Because if this is 1,000, once I've sent my 260 up that way, I now have 740 that are able to go through here, which is great. Then you say, all right, now I've got 740 plus 320. 740 plus 320 is going to be what? It's going to be 1,060. Now that's way too big because I can only fit 840 through this way. So that means I shouldn't actually send 740 cars through this way. I should only send as many as 840 can kind of handle. So now you got to think through, all right, what would I send through here? So 740, 320 to get to 840. So you got to think through the calculation that you would do here in order to help you to get this. And what you're going to end up doing to think this through to figure out, all right, I need I need some number plus 320 that is going to give me to 840. Okay, that's the way you think it through. I'm trying to phrase this in such a way that's going to help you to think this through. So in other words, you're going to go x plus x plus 320 has to be equal to 840. Well, to figure out what x is, you'd simply go 840 minus 320, right? So I'd go 840 minus 320, which is going to be 520, meaning, get rid of all that, this here should be 520. I should only send 520 cars through that way. Now I would have 520 plus 320, which is 840, and then we're home free. Because then what you're going to end up with is 840 plus 620. 840 plus 620. That's going to be 1460, and that's as good as it gets. You simply don't have enough cars to get that to the full 1500 there. All right, so in order for this to be 520, what would this number here have to be? So again, we don't know what this is, but what we can say is that x minus my 260, because x minus my 260 has to be equal to 520. So in other words, what you're going to do is x is going to be 520 plus 260. 520 plus 260, which is going to be 780. And that is going to be your answer. So I tried to do this in a different way as to what we were doing in method 1, because otherwise you're just seeing the same thing twice. So there's 780 there. And what is my answer? Drum roll, please. After this very long video, 6% of the state could do that. 6%. The answer was 780. This question was not answered well. Okay, let's kind of summarize this. I feel that to get the best understanding of this question, it's important that you see both of these methods, because method 2 definitely has its advantages. Definitely has its disadvantages. Method 1 has its advantages. Which one do you like better? Which one do you think is better? I have to go lie down now. I'm very tired after doing these videos. Hopefully you enjoyed this. I'll see you later.